Hi everybody, good to see you all back. So I'm finishing up what turned out to be a very big and involved project. I got into it a lot more than I ever thought I would have to. It looked like it was just going to be your typical repair a bad channel on a receiver. Turned out to be a little more work, well, a lot more work than I anticipated. So at the point that I'm making this, which is going to be the opening part of this series, I'm finished with it and I'm ready to do the very final demonstration of the unit and put that up. This video is definitely going to be multiple parts, and I just want to let you know that up front, but pretty much it is finished and it turned out great. So grab some popcorn, I guess, and sit back, and we have quite a few things to go through that you're going to see, and I'm going to try to keep the parts in these series shorter, and kind of break them up into different sections on how I do them, and hopefully we'll have a lot of fun with this one. So stay tuned, and I'll show you what it is. It's going to be a Fisher Model RS 2010, and if you're not familiar with those, they're actually a pretty good receiver that had a couple problems with the design, in my opinion, but we took care of that and we fixed it. And one of the things about these that I like is they have a really large toroidal power transformer, very good power supply with good reserve power. So once we get this amplifier how we want it, you're going to see they can really perform well. All right, enjoy the video series. My, how looks can be deceiving. So what we have on here is a very nice looking, on the outside, Model RS 2010 Fisher receiver. And this is one of their big ones, and this one has some really nice features on it, but it also has a couple of strange choices that Fisher made. Now Fisher is well known for this generation of amplifier where they use those modules again. So this is another stereo video that you're going to see where they use those Darlington Power Pack modules, kind of like that Kenwood that we just did. And they worked very well. They were good performers, and you can see how nice the case is on this thing. I mean, it's really in very good physical condition. And I really had to decide whether I wanted to be up for a challenge or not before I decided to take on this project, because the look on the outside doesn't really give you a good indication of what's going on the inside. Let's set this top aside. This is a really nice cover. I think you can already see where we're going with this. So there are many problems. First and foremost, this board has just kind of charbroiled. You can see that what's left of the transistors. It's in pretty bad condition. You can see these two Darlington Power Packs have been replaced. I don't believe either one of them is an original Sanyo. They're both counterfeit. Now, a word about counterfeit STK chips. There are ones out there that will function. They're not made by Sanyo. Sanyo hasn't made these chips for over 30 years. But there are some aftermarket ones that are similar. They will work. They are of questionable quality. There are many other ones which may have the, STK 0080 like this one, but what's inside is very different. The components are very inferior compared to this. So you have to really be careful when you buy these days. And if you are able to get your hands on a set of original new old stock Sanyo STK 0080 power packs, you are going to pay top dollar for that. Okay, So again, when you see brand new ones out there, even by reputable sellers, don't believe they're by Sanyo. They are aftermarket, and they're probably not going to be up to the standards of the originals. Now, another thing very interesting about this RS 2010 is the early generations of these came out with what's called an STK 0105. And there are some pretty good differences. First of all, the 0080, this is really supposed to be an 80-watt power amplifier module. And the 105, the 0105, is a 100-watt module, which is more suitable to this amplifier because this is a 100-watt per channel amplifier. So what they're doing is they're taking these 0080s and they're kind of pushing them to their limits. And yes, this is a legit thing. Most of these Fisher RS 2010s are going to have these 0080s in them. I think only the first year of them that came out had the 0105s. The big difference when you look at them, the voltage ratings and so forth, there's only about a 2-volt maximum voltage rating difference between the 80s and the 105s. And if we look at the internal, like the functional diagram of one of these, the 0080, you can see is pretty simple. You have your bias spreader, and you have your 2 drivers, and this is just a complementary output. So you have the NPN side, the PNP side, and just your phase or your bias spreader there, and that's it. Okay, or your VBE multiplier, whatever you want to call it. Pretty simple circuit. If you go down to the 105, and if you notice, the 0030, 40, 50, 60, 70, and 80 all share the same design. The only difference is the size of the components and the maximum rating, voltage and current rating of them. If you go down to this one, it is very different. They have 4 output transistors. They have paralleled outputs for extra power. The VBE multiplier circuit here is a little bit different. You notice instead of 1 transistor and 2 diodes, you have 1 diode and 2 transistors in Darlington configuration. And I think this is just to improve thermal tracking. I don't know. Any of you that are smarter than me, feel free to kind of chime in. But other than that, you can see it's kind of a similar thing. The pinout is exactly the same, so this can be this one down here can be a drop-in replacement for this, but obviously this one is much more robust. So, why Fisher did that? It's probably because Sanyo quit making these, and they had to just go with this, and they're just kind of pushing this to its absolute limit. If you look at the other thing is this is quasi-complementary. So if you notice, it's an NPN and NPN on both sides. This is NPN and PNP, which is pure complementary. Looking at the specs, the 0080 has a maximum of plus and minus 65 volts. The 105 has maximum of plus and minus 75 volts. However, if you look at the typical operating values, it's plus and minus 46 volts and plus and minus 50. So really you're only talking a 4-volt difference in rail voltage. So even if you drove this one up to plus and minus 50, you can see it is still somewhat within its maximum ratings, and you can force this into 100 watts. Okay, the maximum current and so forth is all very similar. So that's what they did. Now, I would never replace one of these with a power pack anymore, simply because you're never going to find one of those 105s. Even the original 0080s were kind of under spec'd for the job that they're being asked to do in here, so they will fail if you drive the amp too hard. And any replacement that you're going to get of this today is probably going to be inferior to an original Sanyo design of one of these. So we're going to use aftermarket discrete component modules, just like we did in the Kenwood, and just like we did a long time ago in a video on the Pioneer SX780 that I did. So you can see this thing has an absolute massive transformer in it. Look at this toroidal transformer. I mean, we're talking, this is right up there with like the Pioneer SX1050, 1080 and so forth. Nice 15,000 microfarad 67 volt caps, although like the Pioneers will have 22,000 microfarad. They're a little bit bigger than these, but with this massive transformer, the capacitors really aren't going to make the big difference at this wattage rating. And again, the SX1050 and 1080, I mean, we're talking 120 watts, 125 watts a channel. This one is 100 watts per channel, so lots and lots of power reserve in this power supply. Nice soft start circuit, you can see. However, that's where the fun ends. This thing is burned up because it's been worked on, and I don't believe these power packs, these are counterfeits that somebody put in. A lot of work is going to have to go into repairing this properly. Worse yet, somebody decided to do an LED upgrade. Oh boy. And they literally just took LEDs, and you can see they drilled holes right in the acrylic. They took these stoppers out, and they make LED replacements for these bulbs here. And they drilled these holes and stuck them in, and they put no insulation on any of these little grain of wheat bulb replacement wires. So these are LEDs now instead of the little wheat bulbs. And look at this, just bare wires hanging out there in space, waiting to short out. So, long story short, that's all fixable stuff. This here, we're going to have to pull this module out, pull the whole board out, and see what the other side of the board looks like. And then we'll determine whether this thing's going to get repaired or whether we're going to have to kick it to the curb a little bit until we can find a donor parts unit to get this board out. Okay, the business end of this board is not so bad, and that's a very, very pleasant surprise. I'm very happy to see that. Now, these resistors here, they're not burned up, they just have that corrosive glue on them, which will have to be cleaned. We have the solder is burned up here on these transistors that cooked. A few things like that, but really, this doesn't look that bad. Okay, the amplifier's out. Let's take a look at something here. If we look at our functional diagram again, you can see pins 8 and 9 is the emitter collector junction of this transistor, and pins 2 and 3 are the emitter collector junction of the PNP. So essentially these should read pretty much open circuit. Okay. So let's check that. So here's the burned up side. Here's the meter. Let's see if we can back out a little bit so you can see everything. And let's go to the bad one first, the burned side here. So here's pin 1. Okay, it goes from 1 to 10. So here's 2 and 3. And you can see there's a dead short there. So the PNP transistor, which is this one here, is shorted. And if we go to 8 and 9, not shorted, and you can see it's mega ohms. If we go to this side, this looks, and you can see again it's climbing, you're reading a capacitor. And if we go on this side, there you go. So chances are this module is still functional. This one, of course, is bad. And the funny thing is, if you look at this, that's kind of painted on. And I believe that this one might be an original one, even though these letters will rub right off. Look, they're rubbing off with my fingers because they're just painted on. Now this one here seems to be a lot more durable. And I don't think this is an original. I'm not sure. Okay, there's some folks that are a lot better than me at identifying the original versus the knockoffs, but you can obviously see. And this looks as if it has never been replaced. This one has been replaced. You can see this flux there where they soldered on it and everything. So somebody tried to repair this at one time. All of this is just completely destroyed. Now, this board is going to have to be carefully cleaned. I'll get some light on the subject. And the reason is that burned carbon there can actually be conductive. Let's see if we can read something on it. Because a lot of times it will actually read as a resistor. So if I just touch this anywhere on here, no, this one's not that bad. That's a good sign, because sometimes this carbon will get so bad that it will actually become conductive. And we don't have that on this. So chances are we can most likely just clean the board very thoroughly after we remove the components from it, and we should be good to just replace the bad components. Okay, the board is out. Both of these chips have been removed. And again, I think this is an original one. Even though the paint is coming off, I think this is what happened with the original ones. They were painted like that. So this one appears to be authentic. This one, I mean, it has a similar kind of number on the back, but you can see the font is a little bit smaller on this one. And again, this is definitely a Darlington power pack. Some of them actually have a little weird circuit board thing with bad components in there, but this one not so much. I don't know if I can get this apart. Maybe we should pop it apart and see what's inside. Okay, so if you ever wondered what one of these looks like inside, here it is. And you can tell your big, the PNP and NPN transistors, the large ones right here. They're fused kind of onto this circuit board, and they're bonded to this backer plate. And if you look very closely, I don't know if you can see these here or not, or if the thing will stay in focus, but you have one small transistor here, one here. See the tiny little dies and the tiny little bonding wires? I don't know if you can see that. And you can see right here a component that burned up. This is a resistor or something in here that burned up. Okay, and then you have two other little tiny transistors here and here. So and then these little black pads here are the resistors. So they're actually a discrete circuit module that are all kind of fused onto the same backer plate for thermal tracking, right? And looking at the schematic right here, let's back this up just a little. All right, so these two transistors right here and here are going to be these big ones. These are the big power transistors. These two little this little tiny one and these diodes, that's going to be back here. All right, and then the two driver transistors here and here are these two, and then all these little black pads you see in there, those are the resistors, and here's one right here that's kind of cooked. And that's that resistor that goes between between the two bases and between the two emitters. So you can see how they're tied to the emitters of these drivers and to the bases of these transistors. So pretty interesting. And these are your bonding wires right on here. When you hear me talk about bonding wires, that's what these are. Now on a power transistor, they're a little bit more robust. You can see them here. But when you look at these little tiny transistors, I don't know if you can even see it. I mean, I can see them here, but look how tiny those wires are right there, how thin. I don't know if you can see that. Just so there's one here and one here, and one here and one here, and they go onto the die. So that's what these are like. Now, again, this is probably a counterfeit, but it's a good counterfeit. It is a functional counterfeit. The fake ones, when you take them apart, they won't have the transistors on the die like this. A lot of the total fake ones will have a circuit board, and they'll have regular looking transistors, you know, that look, you know, like these kinds of transistors, you know, and like these kinds of transistors soldered on here, like, you know, real cheap, the wrong values and everything. These are the actual dies that are deposited onto the backer board. So this is actually a good counterfeit, if that makes sense. Although these components may not be the same quality as the original Sanyos. Okay, so the silicon just may not be as good. Now, if I open this one up, it would probably look very, very similar to this. Okay, but you would see that they are distinctly different than one another as far as the manufacturing goes, but they would have the same or very similar layout. This is still a good power pack, I think, so I'm not going to destroy it. This one was trashed, and you can see right there where it burned up. And that burned up because one of these shorted out. Okay, looking underneath the amplifier at the power supply, you can see that how pristine this power supply is. So the good news is the amplifier board did a really good job of protecting those fuses. Because not only was that STK module shorted out, but our fuses are all shorted too, and that's what they're supposed to be. Ah, come on. There we go. So fuses are all good. So, and yeah, I went really fast because I tested them already. But this is a good thing. So, and looking at this relay here, it doesn't seem to be charred up or burned or anything. So this is going to be a very, very good receiver to restore if we can get that amplifier board repaired. Okay, I have taken some of this electromotive, and this is nasty stuff. You got to watch because it will eat a lot of different kinds of things, especially plastic. And clean this off as best I could. I scraped the carbon down to where I got to some circuit board again. And now what I'm going to do is I'm just going to stabilize these burned areas, these really badly charred areas. And so the first thing we're going to do is we're going to take some anhydrous isopropyl, so it's not going to have any water or anything in it. I'm going to just clean this off a little bit. And you can see I've cleaned it to the point where I'm not really getting much carbon off of there anymore, or any crud from the charring. And this stuff evaporates very quickly. And then I'm going to take some of this Bondic UV cured glue. And this one's getting kind of old, but I'm going to put some of this in here. I'm just going to kind of fill this hole up and kind of go around it a little bit. Just like so. And then I'm going to turn this UV light on and I'm going to cure it. And what this is going to do is this is going to just harden that immediately. And all this is going to do is just stabilize that hole in there and keep it from crumbling anymore. And then I'm going to do the same thing on these other ones. So I'll do this one, and I'll do this one, and I'll do this one. And then once this cures, this stuff is really good. So I'll go ahead and hit this with some light. And if you've never seen this before, this is some pretty good glue. It's very, I mean, it has almost the same quality as epoxy glue, but it cures under UV light almost instantly. So, and you can see how clear it dries. And you almost think that it's not cured, but if you touch it, I mean, it's pretty much hard already, hardened. And that's it. Now this glue has been open for a while, and I've noticed that if you leave these tubes open for too long, they take a little bit longer to cure. When you first open one of these, as soon as you hit it with that light, it immediately cures it. So that's that, and that just is going to ensure that that's going to be okay moving forward. And there you go. So now what we're going to do is we're going to kind of go through and test all these other components and see which ones, you know, what other ones have failed. But I have a feeling that, you know, we're going to probably see some bad ones back here too. But again, I'm just going to replace all of these semiconductors in here because they've all taken a hit. And it looks like somebody has been troubleshooting this, because I can see certain ones of these have been folded over and other ones were not. Of course, I've bent a couple over myself just turning this over, but I don't know if somebody was going through and testing it or what, but definitely we'll have to look at that. And we're going to look at the schematic next so that we can kind of get an idea of what components we're going to replace these with. Okay, making some progress here. Went through the schematics and the diagrams and the parts list, and I looked up all of the components that I'm going to replace on this board. And for the transistors, I went through what I have in stock because I don't want to have to order any more. And I was able to match up the ones that are on the board, the originals, with some replacements that are going to be good replacements for these, and they'll work fine. Also, the capacitors and everything, I kind of dug through and pulled out everything that I think I need. And I think the only thing left that I have to get, and I think I have them, but I don't know if I have the right ones. I know I have the right voltage, but I don't know about the wattage, is these diodes right here. And if I'm not mistaken, these appear to be regular diodes, the symbol at least, but if you look up the part numbers, for instance D15, let me see where it is. Yeah, D15, it's a DNN RD 3.6E-B Zener diode. It's a 3.6 volt half watt Zener. Okay, I hope this is all in there. This can be a little bit confusing until you look at the schematic as a whole, but I'm trying to sort out some things here because D15 and D17 and D16 and D18, that would be these four diodes here. There's 1, 2, 3, and 4. I have them marked with the red paint. And they're in parallel with a 560 ohm resistor. And there's the 560 ohm resistor on these ones, and then these ones were burned to a crisp. You can see those have to be removed. Now what this is, when you look up the part number, D16, so 16, 18, 15, and 17. Let's see here. 15, 16, 17, and 18, and you can see those are 3.6 volt Zener diodes. And first of all, the symbol on here is not of a Zener diode. Second of all, the little dotted line around there would indicate that that's not mounted on the board, although they are. they're in parallel with this 560 ohm resistor. So essentially what that's doing is it's clamping the voltage from going above 3.6 volts in one direction, and it's of course conducting in the other direction. And more importantly, when I measure across it, I was only getting about 150 ohms in both directions. And even with these legs lifted of this, the resistance does go up, but let's see if I can find where I was here, right here. If I go from here to here, you can see I'm still reading something. It's 220 ohms there, and on this side it's also 220 ohms. But if I go to the side that was cooked right here and I read across either one of those, mind you, there are a couple extra components pulled here, I'm reading nothing there and I'm reading nothing here. And what I'm not sure of is what I could be missing out on here, why it would read open and why I'm reading that resistance on the good side. This is a side that's not cooked right here. This is a side that is. They should read the same, and they don't. And I don't know if that's because I have a couple of transistors removed here or something, but you know, looking right here, I don't see anything in parallel with this right offhand, but of course I would have to trace around here to see it. Remember, this chip is not mounted here. This is the module. Why am I reading something when I have both of these components removed here and both of these and they do read the same. They both read 220 ohms with these components out. But on the other side it reads open circuit. So I do have to go through here and check every little component before we replace anything and make sure there are no other shorts or no other failed components. Okay, everything makes sense now. So the reason I was reading on one side different than the other is because on our bad channel there were two additional resistors, R39 and R41, or no, R43, 39 and 43. They're 220 ohms, which makes up for why we were reading 220 ohms. They're on this side, they're right here, and they're across the base emitter junction and of these two transistors. And if you kind of trace it through, there is a signal path through all of this, through this 0.47 and back up, that when you go from here to here, you will read this in parallel with it. And the same thing goes down here. So the fact that all of this burned up here and all of these burned up here, that's why on this side I don't read it, because this is missing as well. And on this side I do, because these resistors are still here, even with these lifted. So everything makes sense. These two, we call this posistor. They're, I guess, what I would call a thermistor. And they're mounted onto the heat sink, and you can see they just go right on and right off of the board, and they go over to the power supply and protect circuit. And I have a feeling these are kind of thermal sensors for the protect circuit. So that makes sense. So now I'm going to start replacing all these components, and we'll be right back. Okay, the board is repopulated with new components, all new transistors and capacitors. I left these ones right here in there, the 2SC2441 and the 2SA1047. They tested good. The TTAs that I have in stock that will replace these are a lot higher gain. I don't know that I want to replace those. So if we need to, we will, but I think these are going to be fine. After a second pass through checking these resistors, I did find that this one in fact is open, and this was right on the side that transistor shorted on the STK module. But I do have new ones of these that I'll replace as well. And I'll just put all new 0.47s in there. This is done. So really now what we need to do is figure out what we're going to do for those STK modules.